The question asks, if Sam offered to cover the full cost difference on a 1,600 square foot apartment for managers he transfers to New York, by how much would he be overpaying those that he transferred relative to the minimum amount they would be happy to accept? First, let's take a look at the current situation in Gainesville. All this information was given to us. It told us that the utility of the managers depended on two things: how big their house was, or H, and the amount of everything else they consumed, or uppercase E. Currently, we pay them $6,000, so M equals 6,000. The cost per square foot is $1, so R, or rent, is $1. H equals 1,600, which means they picked a 1,600 square foot house, and they don't tell us the amount of everything else they buy, but they do let us know that currently in Gainesville, their utility is equal to 7,600 units. Now, little e is the cost of everything else. It wasn't given to us in the question, and therefore we can assume that it's $1. The first thing we need to do is to solve for the amount of everything else that managers consume in Gainesville. We know that there are 7,600 units happy, and they've chosen a 1,600 square foot house. So we can plug in these numbers and solve for E. After a little algebra, we see that the amount of everything else that managers consume in Gainesville is equal to 4,400 units. So we're going to compare two scenarios. One option is to buy the managers a 1,600 square foot house and 4,400 of everything else while they're in New York, because we know that this combination of goods will make the managers 7,600 units of utility happy. So the only way we can move a manager from Gainesville to New York is if he's just as happy in New York that he was in Gainesville. We know that in Gainesville he's 7,600 units happy, and he got there by choosing a 1,600 square foot house and 4,400 of everything else. So option one says, let's just simply buy him the same exact combination of goods, because we know that he'll be the same level of happy. Well, let's take a look at the salary if we chose that option. We'd buy him a 1,600 square foot house, but now housing costs $2 per square foot, so R equals 2 in New York, plus we'd buy him 4,400 of everything else, where it still costs $1, and we see that option one, our salary would be $7,600. Another option is to maximize utility based on the new cost of rent, which is $2, and then to set the manager's utility equal to 7,600. So let's take a look at the new information in New York. The utility function hasn't changed. The rent has changed. R is now $2, and in Gainesville it was $1. Little e hasn't changed. It's still $1. The amount of housing and the amount of everything else are unknown, because we're going to solve by maximizing their utility and see how much they would choose given the new cost of the inputs. But we do know that utility is going to equal 7,600 units, because that is the level of utility that we'd have to make them for them to be happy to move to New York. So we're going to solve for H, we're going to solve for E, and in doing so we're going to solve for this new salary that we'll call option 2. Well, we're going to use the optimization condition to solve for H and E. Well, we know the optimization condition says the marginal utility of housing divided by the cost of housing, or R, must be equal to the marginal utility of everything else divided by the cost of everything else, or little e, in order for us to be maximizing utility. First, we need to solve for the marginal utility of housing and the marginal utility of everything else. Well, that's simply taking the derivative of the utility function with respect to each variable. So the marginal utility of housing is 40 times h to the negative 0.5. The marginal utility of everything else is just 1. Well, we see that we have a h to the negative 0.5 in the numerator, which could be the same thing as a h to the positive 0.5 in the denominator. So we can move that down. Now we can cross multiply and get 40 equals 2h to the 0.5. From here, we're ready to do some algebra and solve for h. We divide through by 2, and we see that 20 is equal to the square root of h. So we square both sides, and we see that the optimal level of housing that we would choose in New York is 400 square feet. Now that we've chosen our house size or our apartment size, we can solve for the amount of everything else by setting our utility equal to 7,600. So we know that we're going to need to set their utility equal to 7,600. Now we want to solve for the level of everything else that they will need to reach this happiness level. So we plug in 7,600 for U, and we plug in 400 for H, and we're ready to solve for E. we do a little bit of algebra, and we see that in New York, they would choose a 400 square foot house, and they would choose 6,000 of everything else. So let's see what this would cost us, the firm, which is their salary. So their salary under option 2 is a 400 square foot house times $2 per square foot plus 6,000 of everything else times the $1 it costs for everything else, or $6,800. To find out how much we'd be overpaying them between option 1 and option 2, we simply need to subtract those salaries. So salary of the first option minus salary of the second option, in this case $7,600 minus $6,800, and we see that if we would rather buy them the same exact combination that they currently have in Gainesville, we would be overpaying them by $800 relative to the amount they'd be willing to accept.